Today, we're going to talk about a little bit about React Spectrum, which is an implementation of Adobe's design system called Spectrum. We're also going to cover some React Aria, which is a set of hooks that you can use to build accessible UI components. So these hooks actually power React Spectrum, so we're going to cover how you can take advantage of both. And a little bit of intro, I'm Danielle, I'm the engineering manager, and today with me we have Devon, and we are on the React Spectrum team. So I'm going to go through some of the components and the benefits from the React Spectrum library, and Devon is going to take you through some of the React Aria demos and show you how they work. So first of all, we're going to start with an intro. As I said, React Spectrum is implementation of Adobe's design system. So Spectrum is a set of guidelines, patterns, and designs that all of the applications in Adobe should be based on. And the goals of Spectrum are to unify our products and to give users cohesive design and consistent and inclusive user experiences. So the design systems, they're more than just styles. And as the name would suggest, they're full and complete systems. So we're going to talk a little bit about the pieces that make up the design system. At its lowest level, there are the design tokens, as you can see here. And these are needed to construct and maintain the design system. So they represent things like spacing and colors, styles, animations as data. And they are centralized to allow unity across the design. So looking at the example here, you can see that there is a base token or a global token, which represents a single value, such as a color. And in this case, it's a blue. Now, these can be used directly, but they're not really tied to anything. So adding some meaning behind them will help with the usage. And therefore, we have the alias and the component-specific tokens that you see here. So they all inherit from a global token, but the alias gives context and intended purpose. And this, in this case, would be the CTA background color. So that is our call to action type components, and then the main block color here, which is the blue. And then underneath that, you can see that there's a component-specific token. And these tokens tend to be an exhaustive representation of every value that's used by a component. So it should say everything you need to know about where a token is meant to be used. So you can see here, it's attached to the button, and then of course the CTA background color. And underneath that, you can see our React Spectrum button, which implements the token for its background color. Of course, we have the components. So complete with defined behavior and interactions. For the most part, they tend to be lower level components that can be used to build a UI. So we've got form elements such as radio, checkboxes, text fields. We have modals, pickers, menus. So one uses these to put together a full experience. And these are some of the components that we have included in React Spectrum. The higher level definition of design comes in the form of patterns. So you can use the design, you want the design system to allow for creative flexibility while keeping the core design consistent. So to achieve this, Spectrum provides some guides on common patterns that are used in our products. You can see here we have cards, we have tables, dialogues, and layouts. These are constantly being added to as the system grows organically. So now that we've covered the basics, let's talk a little bit about React Spectrum, and we'll have a look at the library. So React Spectrum aims to achieve a number of goals. It's accessible. So more often than not, accessibility, it's not as comprehensive as it should be in many products. The difference between just passing an accessibility linter and really delivering a quality experience for those who may not use the products maybe the same way as I would is a really big difference. So we've included accessibility in the API design from scratch and not as an afterthought. It's part of the component, which means it's made it integrated into the way the component works. We follow the Y ARIA patterns, and with help from our accessibility team, we're able to have full keyboard support and touch support in our components. We also test across multiple screen readers, browsers, and devices. Adobe products are used all over the world, and because of that, our library needs to be internationalized. So we support over 30 languages. We also include support for right-to-left languages in which the components mirror for those languages that are read from right to left. And on top of that, we support internationalized date and number formatting for different locales. Responsive design is an important feature of any application. And with so many devices available, we need to make sure that our components adapt no matter the platform. So we make sure that we build for different screen sizes. We also include support for dark mode automatically. So it's pretty common nowadays to have applications offer a dark mode, and we're able to support that based on both the user's OS setting as well as at the application level. We're able to support different scales depending on the interaction mode of the user, so maybe mouse or touch. We're able to figure out using media queries, for the most part, what type of interaction mode the user is using and adjust the set scale accordingly. So for touch devices, they need to have a bigger hit area because you're using your finger. So we adjust for that. And then for scale, when you're using a mouse or a stylus, they have a more precise hit area. So the default for that would be smaller. And as mentioned before, we cover interactions no matter how you use our components, via touch or screen reader, the support is there. And of course, we test this across multiple devices, platforms, and browsers. Customizable. Spectrum is pretty specific with its styles, but we want to give the ability for people to be able to change that based on their own designs. So we allow custom themes on top of React Spectrum, but if you need something with even more flexibility, you can use our lower level hooks in the React Aria library to control how you render. And Devon is going to spend some more time on this a little later. Now let's have a look at the architecture and how we make all of this possible. So it's broken up into 3 parts: the component, the behavior, and the state. Now, not all components have all 3 parts. They use what makes sense. And we're able to make all of this possible by using React hooks. So looking at the state hook firstly. So this is React Stately. Now, this is the state management of a component, and it's meant to be cross-platform. Makes no assumptions about the DOM or the view system. There's no theming or anything Spectrum specific in here. It uses React hooks, and it returns an interface for reading and updating component state. And as I've said before, not all components have a state hook, so maybe the more simpler components, such as a status or a badge, you might not have any state at all. So the next layer is React Aria, which is the behavior hook. So this is platform specific. It depends on the platform API, so DOM here. But again, there's no theme specific logic in here. But this is really the guts of the component. It implements all of the event handling, internationalization, accessibility, and interactions. It's all in here. And it uses the state hook to implement its behavior. And then it returns platform-specific props that you can spread onto your DOM elements within your components. And then we have React Spectrum. So React Spectrum is the component level. This is the view. So it's very theme and platform specific. It renders DOM nodes. It implements the design from Spectrum and takes the styles. And it uses the props that are returned from the behavior hook and the state that's returned from the state hook to provide the functionality for the component. So the question may be, why do we split it all up? Why not offer just a single UI library? And there are a few reasons for this. First of all, we're pretty big into sharing code. So Adobe has a pretty wide ecosystem of products that spans multiple technologies. And with the goal of Spectrum to unify all of these products, we wanted to break down the code to give as much chance as possible to share across the teams. And React Spectrum has the opinion of React and web, but as I mentioned before, React Aria and React Stately have the opportunity to be able to share it across different platforms and different frameworks. And this is something that we're currently exploring. Now, there's always going to be custom UI. Cases and special cases that don't quite fit the Spectrum definitions. And in these cases, we wanted to provide helpful hooks and tools that you can take advantage of in order to build custom UI and still have a high level of accessibility along with cohesive design and interactions. So for example, if you had a custom grid component, it would still have selection. It'd probably still support touch. You would need to follow the Aria grid pattern. that includes keyboard navigation and focus management. So we provide all of those for you to help simplify building custom UI. As I mentioned, React Spectrum is customizable. So the separation of styles allows us to be able to apply custom themes where needed. And we really wanted to take the work that we had done to build these full-featured and accessible components and expose them without tying it to the Adobe's design specifically. So, there's more to a design system than just the styling. You have the interactions and behaviors of focus and accessibility. They all make up the design. And just because you change the style doesn't really mean that the thought that went into those areas is lost. So we wanted to offer that to the community to be able to build with. And then if you want to use the Spectrum styles, then it's all included in React Spectrum. But if you wanted to take the work that we did on these components to make their behaviors consistent across platforms, then we're able to provide that for you. So we're going to go over a couple of cool features in the components we have currently in React Spectrum. First of all, I mentioned the dark mode support. So we supply default themes for React Spectrum, and they handle the default dark and the light color themes. Now you can specify what theme you would like your app to be in. So maybe you only want it in a light theme. However, if you wanted to support your application changing color or changing the themes based on the mode of the operating system and the user preferences, then this is automatically supported. So if your computer is set to dark mode, which you can see here, our components will appear in a dark color theme. If your mobile device is set to dark mode, the same thing will happen. If your customer changes their preference in the middle of a session, then the components are able to pick up that change, and you can see that happening here. So we've worked on making sure our components behave the same or behave in an expected way across different devices and platforms. So for example, we have popovers. They're not really a great experience on mobile. So when you add a popover to your application and the users use this on a touch device, we're able to detect that and render your popover in a modal instead. So another example here is menus. Typically, menus appear in a tray on mobile and touch devices, and mostly, because of the screen size and the hit area for touch. So our menu component is actually it actually swaps between a menu and a tray depending on the available screen size. So you can see here that this is the same component when viewed on a desktop on the left-hand side and on a phone on the right-hand side. So same component, same code, different view. Now tooltips. Tooltips are pretty simple, visually a pretty simple component. The Spectrum guidelines for tooltips follow a very similar pattern to the native tooltips that you see in a browser. But there are a few intricacies that native tooltips implement, which we model after in React Spectrum. So for example, you're going to show one tooltip at a time. There's a warm-up and a cooldown timer. There's a delay for the first tooltip that gets rendered, and then no delay for sequential tooltips. And then for focus, it instantly brings up a tooltip for accessibility. And breadcrumbs, this is our breadcrumbs component. So this is an example of component that follows a pretty specific Spectrum behavior. The breadcrumbs have an Aria pattern, but Spectrum has published some additional guidelines on how they should look. So the breadcrumbs have an overflow behavior here, in which the breadcrumbs collapse into the menu from which you can select. So here you can see the breadcrumb shifting in and out of the menu, which is triggered by a browser resize. And this is all handled in React Spectrum. So we're moving on to dialogues. So this is an example of a concept we adopted to handle more complex UI layouts in our components like dialogues. So for example, as menus, we saw that you could have an icon or a second line of text. So we need to make sure that we weren't taking up space for this optional content when it wasn't being used, while also managing the layout in the spacing between these elements when they were used. So the diagram here shows a standard layout for a dialogue, and we have multiple layouts in which we support. And we're able to do this by using a concept called slots and take advantage of CSS grid. So one of the challenges we had was allowing content flexibility. while also making sure that we were able to control the style of the contents, how Spectrum had defined it. So to take advantage of this, the advantage of this method is we're able to shift elements around when needed without using a lot of props or having the user implement different codes. So you can see here, this is a full screen dialog, but we actually shift where the buttons are positioned based on the limited space when you get smaller. So using slots, we're able to specify where the content should be positioned in different scenarios without any effort on the user's part. Now we're going to have a look at one of the components that we've built so far that has really been more work than we ever thought it was going to be. This is the picker. So the picker is Spectrum's version of a select component, and it supports more advanced options like icons and a second level of text and very custom design. So we couldn't use a native select. So we needed to support full keyboard accessibility. You need to be able to tab to the drop down, open it with space and enter, use the arrow keys to navigate the items, be able to use home and end and page up and page down. And then to select is the enter or space bar, and then dismissing, use the escape key. We also wanted to support type ahead, which is something that native select supports. So once you focus the picker, you're able to type in order to search the items. And you can even do this without opening the picker and still be able to make a selection. So this is an important feature that's included with native that we wanted to support. And it's helpful when dealing with long lists, such as picking a country. Another feature we have is integration with the browser native autofill. Unfortunately, there's no JavaScript event for this, so we had to render a hidden select and handle its on-change event to capture the value when it's updated. We also support internationalization, including right to left languages like Arabic and Hebrew that you can see here. All of the languages, these languages, the entire component is mirrored, as you can see. So the text is on the right and the chevron and the icon are on the left. And then mobile. So screen space is really limited. It's really hard to use a drop-down menu, as I mentioned. So the popover is replaced by a tray, which is a bigger area for the user to scroll. We ensure that users can use the next and previous button on the software keyboard as well, so they can navigate through the form, which is expected with the native select. And then finally, there's the mobile screen readers. Navigating with those, you utilize swipe gestures. So one of the problems with this is there's no escape key for this. So there's no real way to close a picker. So we had to add some hidden buttons or close buttons at the start and end of the list in order to make sure that screen readers could navigate them so that they can escape out of them. So it's kind of a good example of the complexities that exist when supporting different platforms and building components from scratch. So Magento using React Spectrum. Since we open sourced in July, the new Magento SaaS services are using Spectrum, and Magento and all of the other Experience Cloud products are adopting Spectrum over time as well. And I had a couple examples here. Some of the admin extensions in Magento have already started migrating to React Spectrum. This is including the Amazon sales channel, product recommendations, and the upcoming live search offering. So that's all we're going to cover for React Spectrum. There's a number of components available, so you can go and check them out, and we're working on adding more. And now I'm going to hand it over to Devon, who's going to talk a little bit about React Aria.
All right. Thanks, Danny. Let me share my screen. Okay, so as Danny has shown, React Spectrum makes building Adobe themed applications pretty easy. But what if you want to customize the design a bit more? Build something that's your design as opposed to our design. In that case, the React Aria library that Danny mentioned might be a good fit. So as she mentioned, React Aria is a library that helps implement the behavior for your custom components, along with React Stately, which provides the state management. React Aria doesn't provide any rendering or styling, so it's up to you to bring your own DOM structure and CSS. This makes it really easy to bring into an existing React component library that you might already have and make it more accessible. React Aria provides interactions, behavior, and accessibility that can be shared between different implementations of the same component, regardless of the design. If you think about it, a button, or even a more complex component like a dropdown, usually behaves pretty similarly or even the same, even if the design is a bit different. So why are we rewriting the entire component each time instead of sharing the parts that are the same? We built React Aria to be that shared layer, so you can focus on the unique parts of your components like their design, rather than re-implementing the behavior as well. React Aria starts with interactions. Building components work well across devices is really hard. So React Aria provides hooks that implement interactions that work across mouse, touch, keyboard, and screen readers. We have high-level events like press and hover that combine these different interaction models together into a single API, so you don't need to worry about the details of each of these types of interactions. We handle a ton of edge cases and different browser quirks that we found while testing these to ensure a consistent user experience. Moving up one level from interactions, we have Aria. For those who don't know, Aria is a W3C standard that specifies semantics for many common UI controls so that assistive technology like screen readers can make sense of the div soup that we use to implement these components. But Aria is a contract. Since it only specifies semantics, it's up to the developer to implement all of the behavior with JavaScript. And this is the hard part. So there's an additional document published by the W3C called the Why Aria Authoring Practices, which provides patterns and examples of implementing this behavior on top of Aria. They typically specify keyboard interactions that are expected by users of these controls, along with the required roles and states that make them accessible to assistive technology. Adobe has invested a lot into accessibility, and we're lucky to have an amazing accessibility team who we work with to ensure our components meet accessibility standards. So to help give back to the wider community and make this easier to implement, React Aria provides React hooks for each Aria pattern, which provide both the semantics and the behavior together. This way, you can simply spread the props that it returns onto the elements that you'd normally render to implement these common UI patterns and get accessibility and behavior pretty much for free. All you need to do is provide the styling. All right, so let's go through a demo. I want to show you how you can take an existing component that you might have and make it more accessible using React Aria. So here I've got a basic setup already. So you can see I'm using Tailwind CSS for the styling in this case, and I've got some components that I've already made. So when I click this button, you can see I've got a dialog here with kind of a sign up form and some buttons and stuff. So just a basic dialog. But what you'll notice is there's a few issues here with accessibility that I'd like to point out, and then we can try to fix. So first off, you can notice that if I open this dialog, you can see the focus ring is actually still back there on this button. So focus isn't really moving into the dialog properly when it opens. And so if I tab forward, I'll get there, but it should move into the dialog as soon as it opens automatically. The other issue here is that the focus isn't contained within the dialog. So if I tab forward here, I actually ended up down here out of the dialog. Or you can see if I tab backward, actually get back to this button that's kind of outside the dialog here as well. So it's generally recommended that dialogues contain focus within them so that the user can more easily navigate around without kind of going to things that are kind of hidden or outside the dialog. So those are the first couple issues that we need to solve. So here I show you basically the setup we've got here is like we've got an application. I've made this dialog trigger component. That's basically this button. Has this label for the button there, and then you pass a dialog component as a child, and that's what shows up in here. So I've made this dialog component. It's got like a title and a label for the sign up button down here, and then just some contents, a couple text fields and a checkbox. So take a look at that dialog component. So a couple things. We've got here an outer div, which is kind of this fixed position wrapper thing that's taking over the whole page here. We've got, this is a backdrop, so this is that this kind of grayish background color that's kind of covering the whole page. And then this is our actual dialog here with this rectangle. And then we've got our title, which is just an H3. And we pass in our children, which is this whole area down here. And then at the bottom, we have a couple buttons. And when these are pressed, it just triggers this on close prop on the dialog's props. And that ends up closing the dialog. So the state for that is actually managed by the dialog trigger, which renders this button out here. And then it has just a piece of regular React state here to keep track of whether the dialog's open or not. When you press the button, it sets it to open. When it's open, it takes the children, clones those so that it can add this is open prop and an on close prop, and that's how the button here can close the dialog from within it, and that just calls set open to set to false. And this dialog is also rendered into a portal, which puts it at the end of the document body. So if I were to inspect this, you would see this dialog here is here at the end of the document body, and then my actual app is inside this root element back here. So we're getting a nice portal there, which will make sure that we're outside of any overflow behavior that's going on. All right, so let's see if we can fix a couple of these problems, because I mentioned before the focus doesn't go into the dialog, and then it's not really contained inside there either, which would be a good feature for accessibility. So the way we're going to do this is using some components and hooks from React Aria, which is a nice library of hooks to make building accessible components more easy. So first, what we're going to need is the focus scope component. So I'm going to import that focus scope from React Aria /focus. And focus scope, essentially you wrap some children within it, and it will make sure that focus is either contained within there or, and that's kind of the main feature, but it can do a couple other things as well. So let's do that first. So we'll say focus scope contain, and we'll just wrap our dialog element in that. So I'll save that. And now when I open this dialog up, you can see once I've put focus in here, when I tab through, when I tab to the end, it goes back to the beginning. And if I shift tab, it'll go backwards. So now we've got focus containment in our dialog with just one line of code. But I mentioned the other thing was we wanted focus to move into the dialog when it first opens. And actually, we'd like this first input really to receive focus. So we can do that by adding the auto focus prop to the focus scope as well. And then when the dialog opens, it'll auto focus the first focusable thing within it. So now if I click on the button again, you can see focus immediately moved to the first input within it. So already doing pretty well here, improving some accessibility pretty easily. Okay, so one other thing that's important with dialogues is for keyboard users to be able to close them easily. And usually this is done using the escape key. So right now I'm pressing the escape key and nothing's happening. So we need to wire this up. Now I could do this manually. I could add a keyboard listener and all that stuff, but React Aria has a hook for this that will also help us with another feature, which is kind of nice, which is when you want to click outside on this backdrop, it'd be nice if the dialog closed as well. So to do that, we're going to use the use overlay hook. Use overlay from React aria/overlays. Okay. And so what we need to do, and the general pattern with these React Aria hooks, is you pass it some props, and maybe a ref, and it gives you back some other props that you can apply to your specific DOM elements. So I'm gonna say, let's see, let overlay props equal use overlay, pass the props in, and I'm gonna need a ref. Let's see, so ref equals use ref, and I need to import that. And I'm going to apply the ref here to our dialog element so that use overlay has access to it. And you can see here I've called use overlay. This says it provides the behavior for overlays and popovers, menus, those type of things, and handles the escape key. So perfect. So all I need to do now is take this props that is returned and apply this as well to our dialog element. So if I just spread that on there, and I save all this, now when I open up the dialog again and I press escape, dialog closes. And if I click outside, dialog also closes. Super nice. Okay, now one other thing that would be good is when I hit escape, or when I close the dialog in any way, like focus doesn't really go anywhere. Like now, I don't know where focus went. It kind of went like to the page, I think. You can see kind of in Firefox shows you the little outline there. But it'd be nice, and generally what's recommended is for when you close the dialog, for focus to be restored back to whatever opens the dialog, in this case, this button right here. And luckily, Focus Scope makes this quite easy as well. So we can just put the restore focus prop on Focus Scope here, and it'll take care of that. So now, if I open this back up and I hit escape again, you can see focus was restored back to this button right here, and the focus ring showed up. So great, another feature down. Okay, so let's take a look at some accessibility properties here. And we need to use, Firefox has this built-in accessibility inspector that's really good. So we can right-click on the dialog here and select inspect accessibility properties. So you can see this is showing the accessibility tree, and you can kind of ignore the outer ones because there's this iframe here. But for this frame, you can see the accessibility tree. So let's see, we've got things inside the dialog here. We've also got this section out here. Oh, and that's our button behind the dialog. Okay. Well, the other problem here is that like there's nothing indicating to like a screen reader or anything that's going to use the accessibility tree here, like that this is a dialog at all. So we kind of need to fix that problem first. So these semantics are really important, and providing semantic elements is really important because it helps screen readers and other assistive technology make sense of this kind of div soup that we've created here. Yeah, you see we've got all these divs, but like they don't really have any meaning associated with them. So it's really hard for a screen reader to kind of like know what's going on here. So we need to apply some Aria attributes, and Aria is the accessible rich internet application spec, and it provides a bunch of attributes to HTML elements to provide them with semantics. So React Aria implements a lot of this, and will help us out here. So let's close that for a second. And I'm gonna import use dialog from React Aria /dialog. All right, and then I need to kind of do the same thing as I did with overlays here for the dialog. So let's see, dialog props equals use dialog, and I need to pass it the props and the ref again. All right, and then I just kind of also spread those props onto the dialog element. Okay. So I'll open up the dialog again and maybe inspect the Expect this again. Oh, check this out. Now we have a dialog. So now it knows, the accessibility tree is showing that it knows that this is a dialog. So how does it know that? Well, let's just inspect element here and see what's going on. So you can see it's added a role equals dialog attribute here, and also a tab index to make sure that this dialog is actually focusable. And this role here is what's really giving it that semantics. So in the accessibility tree, you can see that it knows it's a dialog. But we do have one issue showing up here, which is that we need a label. So when it reads the dialog, it needs to know like a name for it so that it knows what to say when it's reading the dialog. So it says dialog should be labeled. Luckily, we have an element already. That's the title here in the DOM. But we just need to associate it with that dialog so it knows that's the name of the dialog. Luckily, use dialog makes this pretty easy, and it actually returns a title props as well. And we just need to take this title props here and assign this to our H3 here to associate the title with the dialog. All right, so title props actually. Okay, so now if I open up this dialog again, you can see we've got dialog and it's labeled now as sign up. So how is it doing that? If we inspect element again, you'll see that the dialog here has an aria labeled by attribute. It's got this long random ID string here. But you can see that this ID matches the ID attribute that is placed automatically on the H3 for us. So just by taking this title props here and applying it to the H3, we automatically get this nice ARIA association between the dialog and the title. So we've already improved our accessibility quite a bit just by applying a couple lines of code. Okay, so one other problem here that we notice when we look at the accessibility tree is that this this button that's outside the dialog is actually still visible even while the dialog's open. And that's kind of going to be frustrating for a screen reader user because they're going to be navigating around with kind of a virtual cursor as they move around, and they're going to navigate to this which is outside the dialog, but they don't really know. They're not really going to know that it's outside the dialog and that it shouldn't really be accessed. And you know, sighted users can't interact with that while the dialog's open. So neither should screen reader users, right? So what we need to do is actually make this dialog modal. And modal, a modal means that the user can't interact with anything outside that dialog while it's open. So there's a couple steps to do this. First of all, we need to import use modal from React Aria / overlays, I think. I guess I could put it up here as well. Combine the imports. Okay, so to do this, I'm just going to do the same pattern again. Modal props equals use modal. And actually, this doesn't take any arguments in this case. And then we just need to apply this as well to our dialog element. Now, at this point, it's not actually going to do anything because there's a couple other things that we need to set up. So in order to implement this, what we actually have to do is apply this aria hidden attribute to everything outside of the dialog. And this is kind of backwards from the way that React components typically work. You know, and in React, typically you're only affecting things within your component. But in this case, we actually have to affect stuff outside of our dialog in order to hide it. And so this is implemented by React Aria using a context. And so when use modal is called, it actually tells the parent providers on the page, hey, I've got a modal open now. And then that will take care of hiding everything else. So we need to import a couple other components here to handle that. So first off, we actually need to replace this this portal down here with an implementation of the same thing in React Aria that also handles this modal aspect. And so that's the overlay container component. Sorry, that's actually from the overlays package. And so we'll just replace the portal here with this overlay container, and that's what's going to communicate with the outer providers to indicate that it's within a modal. So we got that, and now what we need to do is wrap our application actually inside of a overlay provider. So I need to import overlay provider from React Aria /overlays. And then I just need to wrap this application in that and save this. And so now when a modal opens, this use modal is going to indicate to the overlay provider that, hey, there's a modal open now. And then this overlay container is going to keep track of where the boundary is between the modal and the rest of our app. So with this, we should be able to open our dialog again and inspect accessibility properties. And now you see that section that we had that's outside the dialog is empty now. So that button is being hidden. So let's take a look at what happened in our DOM structure. If we inspect element again, you'll see we've got our dialog here still, and that's all the same. But if we go to our application, you'll see that it's got this Aria hidden attribute on it. And that's the overlay provider element handling, doing that. And then if I close my dialog, you'll see Aria hidden got removed automatically from this div. And my dialog is gone. So now when I inspect accessibility properties again, you'll see there's my push button. So hiding everything outside of the dialog pretty simply by adding a couple wrappers around our dialog. So now we have a pretty much fully accessible dialog component here. We can tab through it, and it makes sure that the focus is contained within the dialog, and auto focuses it on open. We can hit escape or click outside, and it restores focus back to the button. And we made sure that for screen readers, we're hiding everything outside the dialog. And we made sure that this thing has semantics and is connected to the title and is labeled properly. So now we should, screen reader users should be able to use our dialog pretty easily, as well as keyboard users. So that's kind of how a look at how it works to take an existing HTML structure that you might already have in an application and make that fully accessible using React Aria. So let me go back to the slides now. So that's React Aria. It provides the accessibility, interactions, and state management for many common components, so you can focus on your custom design. It gives you complete rendering and styling control since you are in the DOM structure. Just take the event handlers and Aria props we give you and spread them onto the appropriate elements, and you get most of the behavior and accessibility for free. And you can worry less about cross-browser, cross-device, and assistive technology testing because we've taken care to ensure everything is well tested. We hope it helps make building your own fully accessible components much easier. So how can you get started with React Aria and React Spectrum? First, check out our documentation at reactspectrum.adobe.com. We put a ton of effort into this. There's a lot of examples using the components in different situations, and we show all the visual options that our components provide and lots of conceptual documentation as well about topics like layout, styling, testing, accessibility, internationalization, and more. We also have documentation for each React Aria and React Stately hook on the website as well, with examples of the components. If you want to learn more about Spectrum design, head over to spectrum.adobe.com. This is the website that our design team created, and it showcases all the components as well, but with more design-oriented content. It tells you when you should use each component and variant, and whether another might be appropriate, and documents the behaviors and anatomy of each component as well. And finally, we're open source. So you can check us out on GitHub under the Adobe org. We only open sourced a couple months ago, but already the response has been amazing. And we've gotten a bunch of contributors from outside Adobe, including some entirely new components. So if you're interested in contributing to an open source component library, we'd love to have you. And that's it. So thanks for listening. We might have a few minutes left for questions. If anyone has them, you can post them in the chat. And we also have Eduardo from the Magento team here to help answer questions as well.
Hey all, Eduardo here. If there are any questions, feel free to send them our way. I know like 30 seconds left before Jason's closing remarks.
All right, we're right on time. So thank you everyone for joining, and everyone enjoy closing remarks. And thanks Eduardo for joining too.
Sure thing. Thank you.
Thanks. Bye.
Bye.